In mathematics, magnitude is the size of a mathematical object, a property by which the object can be compared as larger or smaller than other objects of the same kind. More formally, an object's magnitude is an ordering of the class of objects to which it belongs. History: the Greeks distinguished between several types of magnitude, including positive fractions, line segments, plane figures, solids, angles. They proved that the first two could not be the same, or even isomorphic systems of magnitude. They did not consider negative magnitudes to be meaningful, and magnitude is still chiefly used in contexts in which 0 is either the lowest size or less than all possible sizes. Numbers. The magnitude of any number is usually called its absolute value, or modulus, denoted by x. Real numbers: the absolute value of a real number is defined by. It may be thought of as the number's distance from 0 on the real number line. For example, the absolute value of both 7 and a 7 is 7. Complex numbers: a complex number z may be viewed as the position of a point P in a two-dimensional space, called the complex plane. The absolute value or modulus of z may be thought of as the distance of P from the origin of that space. The formula for the absolute value of z equals a plus b is similar to that for the Euclidean norm of a vector in a two-dimensional Euclidean space, where the real numbers a and b are the real part and the imaginary part of z, respectively. For instance, the modulus of a 3 plus 4 is alternatively, the magnitude of a complex number z may be defined as the square root of the product of itself and its complex conjugate, z, where for any complex number z equals a plus b, its complex conjugate is z equals a, b. Recall, Euclidean vectors. A Euclidean vector represents the position of a point P in a Euclidean space. Geometrically, it can be described as an arrow from the origin of the space to that point. Mathematically, a vector x in an n-dimensional Euclidean space can be defined as an ordered list of n real numbers, x equals, x1, x2, xn. Its magnitude or length is most commonly defined as its Euclidean norm. For instance, in a three-dimensional space, the magnitude of 4, 5, 6 is a 42 plus 52 plus 62, equals a 77 or about 8.775. This is equivalent to the square root of the dot product of the vector by itself. The Euclidean norm of a vector is just a special case of Euclidean distance, the distance between its tail and its tip. Two similar notations are used for the Euclidean norm of a vector x. A disadvantage to the second notation is that it is also used to denote the absolute value of scalars and the determinants of matrices, and therefore its meaning can be ambiguous. Norm vector spaces. By definition, all Euclidean vectors have a magnitude. However, the notion of magnitude cannot be applied to all kinds of vectors. A function that maps objects to their magnitudes is called a norm. A vector space endowed with a norm, such as the Euclidean space, is called a norm vector space. In high mathematics, not all vector spaces are normed. Logarithmic magnitudes. When comparing magnitudes, it is often helpful to use a logarithmic scale. Real-world examples include the loudness of a sound, the brightness of a star, or the Richter scale of earthquake intensity. Logarithmic magnitudes can be negative. It is usually not meaningful to simply add or subtract them. Order of magnitude. In advanced mathematics, as well as colloquially in popular culture, especially geek culture, the phrase order of magnitude is used to denote a change in a numeric quantity, usually a measurement, by a factor of 10. That is, the moving of the decimal point in a number one way or the other, possibly with the addition of significant zeros. Occasionally the phrase half an order of magnitude is also used, generally in more informal contexts. Sometimes, this is used to denote a 5-to-1 change, or alternatively 101/2-to-1. See also, number sense, references.